So my name is Fred Niehaus. I've been with Cisco for quite a while. I started out doing Wi-Fi. Just going to give you a little history, and then we'll get into this. I started out doing pre-Wi-Fi. It was probably about 1995 when we made a radio that looked like that, and that radio morphed into something that looked like this. And this was the very first client, Wi-Fi client ever made. And we did that in 1995 when I started. And along about 2000 or so, Cisco purchased us, and we introduced the very first Wi-Fi certified product. And it's kind of funny. We're a founding member of Wi-Fi. So it was 1995. Then we get into 97. We start making these cards and things. We hit 2000, and a guy that I was working with said, you know, this is a great Wi-Fi or great wireless thing, but nothing connects but your own stuff. There's no interoperability. So we helped found the Wi-Fi Alliance in 2000. I think it was 1998 or 99, Networld Interop. One of our guys got together with the very first engineers with major companies that were doing early Wi-Fi, and we created this Wi-Fi Alliance, called it WECA, Wireless Ethernet, at the time, Wireless Ethernet Compatibility Alliance. Turned into the Wi-Fi name because WECA, you know, Wireless Ethernet was a church up in Canada. WECA was West Edmonton Christian Association. So I like to tell that story because it prompted a reason for having a name called Wi-Fi. So we helped found this, create the name Wi-Fi, and I think about 2005 or so it got into the dictionary. And anyway, long story short, you know, we're celebrating 20 years of Wi-Fi because that's when the standards and interoperability happened recently. And I've been doing it, like I said, for about 5 years before that. So my name is Fred Niehaus, ham radio, amateur radio guy, NHCPI, Twitter's Ohio Fred. And I want to talk a little bit about some of the new stuff that we've got. You know, you've probably seen the product line, the 91, 15, 17, 20, 30. Those are our high-end, you know, cool APs, you know, the 91, 20, and 30. You've got that RF ASIC and things, but I want to talk a little bit about something we haven't released yet. And I'm actually kind of fired up about it, and that's the 9105. The 9105 is a very small AP. That's just a marketing slick on it. It's a 2x2 in both bands. It's got an MGig uplink in it. There's a wall plate version of this AP, and then there's a standard, you know, AP looking access point that mounts on the ceiling and things. And it, you know, the use case on this kind of thing, what makes me happy about it is, you know, we're talking about COVID, and, you know, some of our other speakers will talk a little bit about that, but this is a very small AP. I can't tell you how neat it is because it's really lightweight. It can be deployed anywhere for like remote workers, for teleworker. You know, the wall plate will work out great for a teleworker because it's got ports on it for other devices. You know, it's, you know, the traditional use case are things like, you know, hotels, hotel rooms so that you can plug in the IP phone and all that, or dorm rooms. But now it's remote workers and, you know, quarantine users, people like that. This is the engineering definition of it. It's kind of a little bit dry, but the, you know, the product name is Catalyst 9105 AX, AX for 11AX. And like I said, it's a wall plate and a conventional, you know, looking AP. It's got, not only is it 2x2 in both bands, but it's also got all the Wi-Fi 6 features. You know, it's got the IoT gateway ability, the built-in, you know, Zigbee, BLE, Thread. The wall plate unit can actually do PoE out, supports about 200 or so Wi-Fi devices per access point. But I'm harping about this size because, you know, we used to get a lot of grief years ago about the size of the products, you know, and you know, and the weight of the products. This whole Catalyst line, we changed the name from Aeronet to Catalyst because we hired Pininfarina, the same people that do the Lamborghini and Alfa Romero, other car designs, to give us a really good streamlined look. So, you know, in the past, the APs used to look different. Each one you could look at the ceiling and go, that's a whatever, you know, because you could just tell by the way it looked. Now we're trying to get everything to be uniform, to be as small as possible, as robust as possible. But this 9105, if you look at how little that thing is, and I can't, you know, really crow about that, you know, enough, because when you look at like this product here, when you look at the AP 4800, now we won a Pioneer Award for that product. This product is about 5.5, 5.4 pounds. This AP is about a half a pound. It's not even the size of It's not even the size of the antenna array. It's really, really small. Probably the best. It's hard to really understand the size in cameras because it always fools you. But I showed you the very first Wi-Fi card. The last Wi-Fi card that we made was one of these. It was a dual band one. But if I look at that size wise, that AP is not much bigger than the card. And if I do that same trick with the AP, this is a 9130. Look at that. It barely covers the logo. I mean, that should give you an idea how small this AP is. It's also an AP that's built really well. I can take this damn thing apart, pull the screws off of it and wing that somewhere. And if I can get this board out of here, and I'm sorry for the delay, but if I can get it out, I'll show you that the inside is shielded. The antenna side is all metal, so it's got a great ground plane to radiate off of, and the radios are shielded as well. So you got double shielding on the radio can, shielding on the inside, shielding on the ground plane. You can't really make a more robust AP. I mean, it's very small. The wall plate is the same thing. It's just, it's kind of, I'm kind of excited about it because the last AP that was that size was the 350 that we made years ago. And it's about the same weight, by the way, too, just about a half a pound. It's real small. The bracket on this AP is called an Air Bracket 8. It does not use the conventional Air Bracket 1 and 2 that we have with every other AP. And I hated that, but here's the problem. The bracket from the original AP is much bigger than the AP is, right? So we made a new bracket, smaller, tiny, that'll go on the back of the unit. And if you take a look at the side of it, the port's got a gigabit Ethernet port, a console port on it. It's got a reset button on. Very, same flow and look and feel of the other APs. When we look at things like the wall plate, this has a Kensington lock on it too. But if you look at the wall plate unit's got a side Kensington lock. It's got a USB port. We did not put the USB port on the AXI. We only put the USB port on the wall plate because we're trying to get size thermals and everything as tiny as we possibly could. So this particular AP, the wall plate, is better suited if you have some application for USB or if you have a hotel mobility or hotel or college dorm, something like that, because you can mount this wall plate right on the wall and there's an uplink port. And that uplink port will take you. In fact, that's an MGig port and not a gigabit port. It's an uplink port, and then there's a pass-through port. You plug the Ethernet connector into that, and that if you have an IP phone or something that you want that's in that wall jack. Wall jack's got two Ethernet cables sometimes. Plug the secondary one in there, and it pops out on the bottom. So it's nice because if you have a dedicated IP phone Ethernet drop or something in a hotel room, you just flow it right on through and then plug the phone in the bottom of the AP. This access point also has a console port and it's got 3 Ethernet ports. The first port can do power over Ethernet 802.3 AF, which is 15.4 watt power, provided you power it with 30 watts .3 AT. If you can give the wall plate full power, it can replicate PoE out that port as well. So that's kind of neat. The one thing about these APs that are amazing is if you look at the 9105 AXI, that small AP that I just whizzed, that it's 11 watt draw. I mean, this thing has got full Wi-Fi 6 functionality. It's got the faster processor, more RAM, all the hardware that you want in the AP for performance. But it doesn't have. It's not a 4x4. There's not 4 transceivers in each band. There's only 2 transceivers in each band. So we were able to really optimize this product at 11 watts. So I think that's amazing. And even the wall plate AP will run on AF power down around 13 watts if you don't have requirements for USB power out and you don't have requirements for PoE out. So, the idea here is everything at 11 watts. Now, I've got a kind of a busy slide just to eliminate the questions. Well, what do the other products draw? Well, I've got a reference slide here where I put all the products down and exactly what their PoE consumptions are. I'm not going to dwell on that, but have it. The 9105 wall plate and infrastructure AP, the MTBF, mean time between failure. I want to touch on that a little bit. I'm always getting pushback on that because the competitors the competitor's MTBF is higher than yours. I'm like, well, hell yeah, they measure it at 25C. You know, if you measure an MTBF at room temperature or 77 degrees, you know, that's the longest, best time you could get. Move that thing to 104 degrees where it's going to be in a hot warehouse or a manufacturing environment, and then see what your MTBF is. And so I give you the MTBF here on 25, 40, and 50, just so that you have them. And if you're ever looking at spec sheet readers, that kind of noise, throw them the 25C, I suppose, if you're a spec sheet reader. This is just a list of all the software versions that line up with all the products. I kind of thought that would be a little bit helpful, especially since this 9105 is a brand new AP. So that kind of introduces the AP, tells you what it's about, why I like it. I'm really thrilled about it because it's just so small and has so many opportunities to, you know, if you got a garage, you know, a parking garage, throw that damn thing up in there and people in the garage can know when it's time to go to their doctor's appointment, or just, you know, there's lots of different things you can do with it. So I'm going to stop for just a second. And if there's any questions or anything you guys want to ask about that AP, we'll hit that. And then I want to start talking a little bit about some antennas.
I have a quick question, Fred.
Sure.
Fred, given your deployment scenario for this access point in dorms and things like that, there's a lot of unplanned networks, and 802.11ax is very suitable for unplanned networks. What features have you deployed in this access point that are specifically, you know, AX specific?
Yeah, a lot of the elements of 802.11ax is more complex modulation, so you can get more data through in a given radio. So when you've got a phone, they talk a lot about these APs being, it's an 8x8 and it's a 4x4 and all, it means it's 4 radios or 8 radios. But a lot of times that phone's got one radio because the maker of that phone at the time is told, look, if you put a lot of radios in here, you're going to eat my battery life, going to make my phone bigger, heavier, get it hotter, blah, blah, blah. So the features in 802.11ax are things like more complex modulation, being able to get more data through at a given time. There's this thing called OFDM and OFDMA. And basically the fastest way to describe that would be in previous generations, OFDM, a train pulls in, all the doors open up, and maybe one guy gets in a car, 2 guys get in the other car, a girl or 2 go in the back car, off that packet goes. With OFDMA and Wi-Fi 6, you're like packing all the cars, and that one packet is being sent out at its most optimal performance. You're getting more data out. So the idea here is when I talk about the antennas a little bit, I'll talk about why you can create 2 different cells and things. The idea is to get less users on the band, or get the utilization lower for faster. So the nice thing about this AP is, as a 2x2 AP, it has all the features of Wi-Fi 6 that help with spectrum enhancement, to be able to stop that jitter and to stop that delay, just get the packet out.
So if I can jump in there, Fred, and just ask for clarification. So is supporting 1024 QAM, is doing BSS coloring, and what size resource units is it going down to on your OFDMA systems?
You can have up to 32 RUs, I believe. Off the top of my head, I'm not sure when you scale down the radios how many I'm going to have. I can get back to you on that. Off the top of my head, I haven't looked at it. Okay,
that would be great. Thank you.
Sure.
Hey, Fred, we talked earlier about the new APs. They've got spectrum intelligence. I don't believe they have an RF ASIC in them, correct?
This particular, the 9105 series does not have the RF ASIC. This was designed mainly to be a low cost, easy to pop out, like popcorn, drop these things around, it's designed for campuses, hotels, things like that. If you're going to put something in a hospital, something like this could, the wall plate could live in a hospital room, right? But I would want conventional APs in the hospital, like 9120s and 30s, with the RF ASIC to be able to do full spectrum intelligence, know when I've got interference, things like that. This is going to have to use the Wi-Fi chipset built into it for any sort of spectrum intelligence.
Awesome, thank you.
Okay, with that, I'm going to talk a little bit about antennas. The reason I broke this into 2 sessions is because, or 2 different topics. The first one, I wanted to cover that 9105 because we haven't released it yet. I think it's really cool to get that out to you guys early to see it. And then in the field, when you deploy products, people don't always understand a lot about radio and antennas. And I just kind of wanted to try to go through a little bit of that. If you don't need an external antenna, if you're in a carpeted environment, you're just putting it in the ceiling, you're better off without external antennas because, it's more attractive, it's smaller, it's easier to install, a lot of things that are positive with units that don't have antennas. However, units that don't have antennas are limited. They radiate in a 360-degree pattern. You can't focus it. You can't change the cell size. I mean, you can change the size from a big size to a little one, but you can't cover different areas. When you go into an external product, you can use higher gain antennas that are on, the antenna on the internal one is limited at like 4 or 5 dBi. I can use a 13 dBi, a much higher gain antenna with the external models, and that allows for farther range. When you have an antenna and you focus it in a given area, it's got two benefits. One is it goes farther, it can hear the client better at a far distance, but because it's focused there, it's kind of like your vision. If you're looking one place, you're not seeing the noise behind you. So other APs and other, RF problematic things kind of go away in a lot of times with the directional antenna because it's focused in only one direction. It's not picking up crud noise everywhere. So a lot of good deployment places for these things are high ceilings, manufacturing environments where you want to aim an antenna one way and aim another one to cover two different areas. If you've got a hazardous area, like maybe you're a coal mine or a place that's got hazardous gases and things, sometimes you can't have active components in that area. So you could put the access point, inside, away from that area and put the antenna outside. Or the same with maybe you're a freezer and the tow motor drives into the freezer and the freezer's all metal and, as soon as it goes in there, it's dead, because it's an RF cage. Well, you can put one of the antennas in a freezer, out of a freezer. There's just lots of reasons why you want external antennas. And
hey, Fred, real quick, could you just explain a little bit? Because I think it's important. I think a lot of people overlook it. The distance of APs off of a floor. Could you just go into a little bit about how high is too high and maybe specifically for these particular APs?
Sure. When you look at a product like the 9130 or any of them, you've got an antenna that's very fixed. Okay. It's this this little element right here. And when the antenna is mounted the way it's supposed to be on a ceiling like this, it radiates down and outward in a 360-degree pattern, but it's limited to whatever the gain that antenna is. And once you start going higher and higher and higher, part of the problem is that if I've got more than one access point, say I've got, I've got the access point here and another one here, and we're way up high on a ceiling, the strong signal from this one is at the same exact plane as the other AP, way up there at 35 feet in the air, however high it is. So they start to hear each other. And then RRM says, hey, I got a great signal over here. I'm going to start turning power down. Well, it's turning power down. It's killing your client down below that's 35 feet trying to get up, right? So sometimes it makes sense, to use a directional antenna like a patch antenna. They got antennas like this one. It's basically a 6 dBi patch. And you could put something like that up on a ceiling and angle it down, 35 feet to cover a long aisleway. There's no one way to do this. If you use the features that I'm going to talk about a little bit called flexible radio architecture to create, like 2 5-gig radios, things like that. You can do that up in a manufacturing area and cover it. And, but these antennas use conventional what they call RPTNC connectors, right? There's different kinds of connectors out there in the industry. There's N connectors, RPTNC connectors, and when you're trying to make a decision as to what to do, it's kind of hard to really understand that. So let me dig into that just a little bit.
Right. Let me ask a quick question, and
Sure.
I think you're probably going to cover this, and you can absolutely tell me that, and we can move
No
on.
worries. Go for it.
One of the problems I see with a lot of access points, and I'm curious on if Cisco's this way, is you guys you're adding a lot of extra radios in, right? You're either adding radios in for diagnostic purposes, for 802.15.4, all of those other radios. But often those radios aren't actually hooked up to antenna lugs or anything else, right? So as soon as you put a directional antenna on that, the reception and the signal coverage that you're getting for those additional radios are not what you're getting from the client serving radios. So I'm seeing that on APs across the board, and I'm not putting it specifically on Cisco. I'm curious to hear from Cisco about that. That obviously creates its own problems, right?
Sure. Couple things. If you're using a feature like BLE, right? BLE require, it beacons, right? So you want the AP in the near field of the person and beaconing, right? If you go to a directional antenna, it's going to be going where you're pointing it, right? So you have to look at it. You have to take into consideration that we did an awful lot of things with the 9130, because the 9130, if you take a look at the two pictures here, the 9120 has 4 RPTNC connectors, and then there's a 4-port dart on the side of it that allows that to bring it out. So by default, you have 2.4 gig and 5 gig on the 4 RPTNCs. That way you can take that antenna I just described to you, screw it right in and go. Now, in that case, what happens is you have a 2.4 gig radio that's in 4x4 mode. When you decide, gee, I'd like to use the IoT functionality or beaconing or Zigbee or whatever, what we do is we shut off port D, one of the ports on the 2.4 side of the AP, turn the AP into a 3x3 for 2.4 gig, and then a 1x1 to do the BLE beacons. So in that case, if you screwed this patch antenna, 6 dBi patch to this antenna, and you pointed it in a given way, that's where your beacons are going to go, because I don't have the ability to beacon from within the AP because you've asked for external antennas. When you go with an internal unit, I can lay all those elements inside there, and I can keep them to where they're all in a uniform 360, no focus or anything mode, right? But to take it one step farther, and I don't have a slide that covers this, so I'm just going to talk about it a little bit. When you go and you switch to when I decide I'm going to take that bottom one, that 9130, and I'm going to plug this antenna in, boom, I plug it in. Now I've got 2 sets of 4 cables. The first set, A through D, do all of the 2.4 and 5 gig Wi-Fi. The secondary set will do the 5 gig in 8x8 if they're together covering the same cell, or you can say, I'm going to break it up and I'm going to do a 4x4 Wi-Fi 5 gigahertz AP this way, and maybe a 4x4 Wi-Fi 5 gig and 2.4 that way. When I do that, the 2.4 is only going out the primary, 4. So I can't send anything Zigbee or out the secondary 5 gig. So if I have 2 antennas going 2 different ways, the BLE and stuff is only going to go where the primary one is. And one thing that's not documented too many places is the RF ASIC that listens for things like interference and determining whether or not a channel is clear to use or not, and all of that. Well, what do we do with that? We actually use 2 ports on the RF ASIC, and we mux out the last port antenna on each connector for the RF ASIC. So even if the RF ASIC is pointing 2 different directions, we know which antenna heard it, and we can respond to that 5 gig only without trashing the whole damn thing. So there's a lot to it. But what question specifically do you have, if any, on how it works?
Well, I think you actually answered that really well, and it's also really useful to know about the way you're attaching the RF ASIC. That really kind of changes design methodology, in my opinion, with antenna placement. I do have one follow-up question. I know in the past it's been this way, and I'm curious to see if it's still that way with AX and the latest APs. Cisco in the past has only beaconed for Wi-Fi out of the first antenna lug, right? Is that still the case? And my the argument I often make with other wireless engineers is, if that's the case, we have to be absolutely certain that we're orienting the antenna that's on that first lug correctly, or we end up cross-polarizing. Do you feel like that's a challenge, and is that something that we have to?
Yes and no. I mean, we beacon out the primary. That's more in a 2.4 world. What I'm thinking out loud is that, yes, if you're doing legacy data rates, we beacon out that way. I believe we still do it with Wi-Fi 6, but we've changed a lot of the radio. We're using, my Cisco badge says no technology religion, right? Well, that's true. We started out making APs using a Marvell chipset because we could take our Cognio acquisition, that what was basically the genesis of the RF ASIC, if you will, and build that right into the Marvell, silicon. And so we were kind of like tied to the axle there, but the thing is there's a lot of, as these chipsets go out, right? We made a 9117 is an 8x8, but it's not the 9130. The 9130 can do everything and pass all the Wi-Fi things, but the 9117, they were still making the spec at the time they were doing it, so that chipset was limited, right? So what I'm saying is these chipsets, the core chipsets and how they work are very similar. So I don't think I'm not sure that beacon thing's going to bite you or not. I would look at that and do some testing on that. I've not seen it to be a problem, but it could be. Certainly wouldn't lie to you and say not a problem. But I would. The problem with this kind of a talk is I'd rather, if I know the truth, tell you. If I don't know, tell you I don't know. But and I'm just thinking out loud that I don't know that we're going to be doing things a lot differently than our competitors do when we're using the same core chipsets.
Yeah. And we appreciate the honesty. Thank you.
All right. Okay, so now I'm going to talk a little bit about the 9120, because remember I told you that the difference between these two here is the 9120X has RPTNCs and a 4-port DART. The 9130, we got rid of all the RPTNCs and we have an 8-port DART on the bottom. So I want to touch on the 9120 and then dig into the 9130. So if you look at the 9120, you can use a 4-port adapter that will get you to RPTNC connectors. And this product has two versions. It has a Catalyst 9120 and a P version, professional install for antennas up to 13 dBi. Using the 9130, we don't need to have a special version. But looking at this product here, it's very straightforward. By default, you could just put dipoles on it. Make it look like the conventional AP. Put it this way if you want, and they're all dual band. So you don't need the DART. If you're running in dual band mode, you don't need the DART adapter or anything like that. If you choose to take this product and say, you know what, I want it to be, let's look at the next slide. Say I take this product and it's dual band 5 gig 2.4, but I decide, I'm willing to sacrifice that 2.4 to get 5, right? So if I do that, I can switch it into 2.5 gigs. Now, once I do that, I can't have 2.5 gigs on the RPTNCs on the top of that product because you're at the same band, same frequencies. You just can't do it. So as soon as you switch to dual 5, we take the secondary 5 gig and we go out the DART port. And now you've got a situation where you have this antenna, maybe the patch antenna is on one of the on the RPTNCs, and it's doing 5 gig only at that point. If you choose dual 5, if you choose 2.4, it does 2.4 and 5 on that. And then the other DART connector allows you to plug in a separate antenna for a different direction. So it's a lot cleaner to do that. I like the DART. We did this whole DART approach mainly to eliminate 5,000 of doing this. If you've got to install something, my mom had a minor stroke recently. I was at the hospital looking at that, and I'm like, that antenna isn't even screwed on. One's pointing this way, and things just kind of degrade sometimes with RPTNC connectors, and it's nice to be able to plug in everything with a DART. If you look at this product also, this does something no other AP I think in the market can do, at least none I'm aware of. There may be a competitor that does it, but I don't think so. If I wanted to, I could send, instead of having 2.4 and 5 gig on the top, I could send 2.4 out the DART. I could actually split this into single band products. Why would I want to do that? Well, maybe I'm the military and I want to take that 2.4 and upscale it to a different frequency, or I want to go do something else with that, totally unrelated to maybe what most people would do. But I fought to have that ability to be able to switch things in and out on RF and give you the flexibility that you want to be able to do it. So that's kind of the 9120. The 9130, like I said, that's our flagship. That's the best product that we make. That product is a true 8x8. It's got this tri-radio, which means it can do dual 5 and 2.4 gig. When the thing ships, it looks exactly like the 9130 AXI, like the internal one, except there's a yellow cap there. You pull the yellow cap off, you now have all your 8 antennas, and you have 16 lines of digital. And the idea here is a single insertion. You know, if I wanted to install this product, I don't have to screw all those RPTNCs, do the cable management, all the mess. You know, it's a one plug-in, I'm done. So that's really where it shines. If you look at how that breaks down, the default mode is you've got 5 gig and 8x8, 2.4 and 4x4. They all flow out the DART. If you look at how the DART is, and I didn't put the RF ASIC and the IoT and stuff on this thing, it's a pretty simplistic chart, but A through D is dual band, and the IoT goes out D. You know, we'll shut off D and put it in 3x3 mode if you need IoT out of it. The 5 gig is the secondary 5 gig, or it's the primary 5 gig if you're running in 8x8 mode. Now, as I mentioned before, with the 9120, you had to have a professional version if you wanted to use antennas 13 dBi or so. What we did is we made two DART adapters to get you to conventional connectors. The first DART one gives you RPTNC and allows gains up to 6 dBi. If I want to use a 13 dBi antenna, there's a DART with N connectors, and that way it'll screw onto the stadium antennas, things like that. We're designing a lot of different antennas for this product. I'll touch on a few of them in a bit. But, you know, why do you want to go from 8x8 to 2 4x4s? That's probably a question. You know, what's the benefit of this tri-radio, right? Well, if I wanted to send the signals into 2 different areas and create 2 different cells rather than an 8x8, I now have that ability to do it. And I'm the only product that I know of that can do that today. And, you know, not all use cases benefit dual 5 gig. I mean, you know, you might have a case where you're in a convention center or something and you have, you know, tons and tons of Wi-Fi 6 clients. And you know what? I want multi-user MIMO to work in its full bang mode with 8x8 and everything running. You know, I might want it in 8x8 mode, you know, or I might say, I'm going to take part of that convention area or whatever, break it off into 2 different cells, is 5 gig this way and 5 gig that way. You know, it's all about, you know, flexibility. You know, I mean, marketing people, it's investment protection. Yeah. It's about flexibility. It's about being able to take that RF and do the things that you want to do with it. Maybe I want to make a 5 gig cell outside and do 2, 4, and 5 inside. I could split it out and cover a park area or something. Question?
Yeah. So you mentioned earlier that you're working on a variety of antennas. It still seems like there's every once in a while a missing antenna that I might need for a design. Can you comment on third-party antennas or compatibility by any chance?
Absolutely. Let's hit that real quick. So I can retire off of the things Cisco doesn't address, okay? And there's a lot of antennas and things out there. And we've taken, you know, Ventev is a great partner. Exceltech is a great partner. These people, you know, we're allowing them to make, we've given them the full specs on this DART connector. So they'll be able to make unique antennas as well. Now, what's neat about this DART connector is that once it goes in, you know, I had a picture of it earlier and I showed 16 lines of digital. We can read what is inserted in that unit, right? So we're working with partners so that when you take a partner antenna and you put it in, it'll know it's an Exceltech or a Ventev. It'll know what its gain is. You know, we're working on trying to build up a partner ecosystem to work with that. But what's nice is that they have that spec. When I do something simplistic, like I say, these 2 DART adapters, there's very, very limited logic in that DART adapter. The logic in the one for 6 dBi, it's just jumps so the GPIO pins and the things say, this is a 6 dBi antenna. That's all it is, right? The 13, it's 13 dBi. It doesn't tell me whose antenna it is, what it is, because it's not using all of those 16 lines of digital to be able to do that. So some of these partner antennas will just use that nomenclature. They, you know, the partner antenna may only be 6 dBi, so they just, you know, they might put the logic in the DART for 6 dBi only, you know, and you plug it in, it just runs. We're working to try to get them to give us all the data on the antenna, you know, the gain, who makes it, all of that, maybe even the serial number, and get that stuff bubbled into the higher, you know, management layers and things.
Well, with the 13 dBi DART adapter that you've got there, it does reduce the transmit power of the access point to compensate for the assumed 13 dBi antenna, correct?
Exactly. So part of the problem is that when you don't do that, your out of band emissions, your noise, and everything creeps up. And then, if you look at a spectrum analyzer, it's like, you're not good. There's a lot of our competitors, especially the ones that aren't as big. They're not our big competitors, but the littler ones. They just put that stuff out, and then they get found in violation, have to do recalls. And Cisco's got deep pockets. The last thing we want to hear is that we put 5,000 things up at 35 feet, and now it's not legal. Who's going to pay to rip it all down? We build this stuff with built-in safeguards and things to prevent that.
So now we're no longer responsible for going in and setting antenna gain. It's doing it automatically. Is there a way of overriding that? So let's just say that we're using a 6 dBi antenna that actually has N-type lugs on it. So we're using the 13 dBi dart that's actually only 6 dBi. Is there a way of overriding that, or is it just
well? If you were to plug in a 6 dBi antenna, a dart adapter, you'd have RPTNCs. If you all of a sudden then put a 13 dBi antenna on it, okay, you could argue, well, I went in and I turned the RF power down. I did these things, and I'm okay, right? And you may be okay, you may not be okay. The problem with that is can you defend it, right? And what happens is you might do something that's totally legal and defensible for you, but then the IT guy leaves. A new IT guy comes in, he defaults the AP, it's running at full power, he's found in violation, and the next thing out of his mouth is, well, Cisco sold me this, ain't my fault, it's not legal. So we do all of the things to prevent you from going left to center.
Okay.
Can you go left to center? Oh, well, yeah, I could take that 9105 and take it apart and bring the antennas out and do all kinds of things that may or may not be legal, and that's why I love that 9105, because it's so little, and it's just, I can put 3 of them in an area and take no space, So.
Right. Yeah.
But a good RF engineer will make sure that you're in regulatory domain compliance at all times.
Right. Absolutely. Yeah. And it's not so much, I'm not so much concerned about whether or not I can exceed, compliance. It's more about if for some reason I'm using a lower dBi antenna that happens to have, say, N-type connectors, can I enable it to put out that higher power? In general, let's be honest. In general, if we're coming close to matching our clients, we're not going to get close to that anyways. But that was just kind of I just wanted to know if that was a software setting.
If I gave you that knob, it would be hard for us to defend it if it was running that way, right? Like RxSOP, which to get off tangent a little bit. Sure. RxSOP, receive start a packet. I call it receive squelch, because you're turning up the squelch so it doesn't hear, right? And if you do that, you can run an environment. I've got an AP that's 40 feet away or whatever, making all this damn noise. I could RxSOP that thing all the way up to I don't hear that thing. I can keep running. And, is that a good thing to do? Well, what happens if you're your last day at work, you turn RxSOP on, all the APs so high they can't even hear them, and you check out? How are you going to figure that out, right?
Sure.
We try to do things to keep you from going left to center. If you throw money at it and time at it and skill, you can do damn anything you want.
Okay. Thank you.
Hey, Fred, I have a question for you. On the 9130 datasheet published by Cisco, and I hate to put you on the spot with this question, but it says on there that the tri-radio mode and uplink multi-user MIMO will be available in a future release. Can you confirm that it's actually available today in today's release?
Yes, I believe it is available today,
Okay.
with the latest code. I'm not a lab rat. I mean, I haven't tested a lot of the things, on the end of things, but yeah, if it's not on by now, it's a fair grouse.
Then it must be a documentation
the spec
problem.
sheet, the problem with the spec sheet, let me hit on that. Every time you write a doc, and we do this all the time, we create matrices and we say this works with this works and this works. 2 weeks after you've done that, it's old, right? And I think that spec sheet likely needs revised. And if I'm wrong and it's still not in there, when I get off this call, I'm going to make sure it is and push it hard if it's not.
The compatibility matrix seems to indicate that it's currently supported in shipping.
Yeah,
code.
I believe it is.
Cool. Thank you.
Okay. So I explained why you might want to try radio, why you might not. A lot of different things. This is a slide that's older than I am, I think, but it kind of it tells you a little bit about before there was Wi-Fi 6. you had to do things that would make channel utilization get lower, right? So, you know, if you're on a single channel on an AP with omnidirectional antennas, everybody's on connecting at whatever speed they connect at. The people close in connect at a fast speed, far away people slower speed. In that kind of a scenario, you got like the channel utilization is like at 60%, and you know, for just to put a number on it, right? If I can take the AP and use this FRA flexible radio, create 2 5-gig cells, make a micro and a macro, then the people close in connect at their more uniform, faster speed. The farther ones connect away at their slower speed. And I've taken 2 channels now instead of 1. So instead of 1 channel, 60%, I'm on 1 channel at 20 and another channel at say 24%. So I've dropped it from 60% down to 44% and also split it across channels. So the takeaway is the user gets less retries. It's a better experience. You know, now BSS coloring, a lot of other things are trying to do similar things by turning power down. If you're a client, we did this on the AP side. Unfortunately, we had no ability to change it on the client side. So BSS coloring will kind of let it know about things, let them coexist, turn power down a little bit on them. And it's a more granular and probably a better way of doing it than this. But this, today with legacy clients, is still a huge thing. So, you know, it's important to be able to do those kinds of things. So I mentioned the antennas and the fact that you could take an antenna like this can antenna here in the middle, and with a 1 insertion, plug it directly into the AP and be done. That makes installations easier. It makes a lot of things, you know, better to work with. We've got 3 antennas that came out the gate when we released the AP. The 9101 is a ceiling mount Omni. In other words, instead of putting the AP in the ceiling, you could put the AP above the ceiling in a metal locked box and put just the antenna down below. You know, that's one option. Then there's a pole mount Omni, the middle one, where you, in a manufacturing environment, you might put that on an eye off to the left of an I-beam to cover a 360. And then there's that 2566 patch I told you about. You know, that antenna I was waving around, that flat panel one. You know, instead of having a flat panel antenna like this and then a cable mask go into the AP, what we did was we created this new look. We made the antennas actually look like the APs. We put an LED in them so that they flash. We you know, so it mimics the LED on the AP. All 3 of these antennas have LEDs on them. We changed the design of the 6 dBi so that you could use a bracket 9 behind it, stuff the AP right behind the antenna, and have a directional, you know, a directional 6 dBi antenna to go down a hallway or in a manufacturing environment, other places, and have it look like the AP. It's just a little bit bigger looking AP, and then all the cables are hidden behind it, and it stops this rat's nest that you see over on the right, you know, where you got cables going one way and another way and all that. So that's kind of neat. There's a list of approved antennas for this product. You know, I just took this right out of the hardware installation guide. You know, just so if I'm going to give you the POE draw, I might as well give you the antenna, you know, approved antennas. To go back to Sam's question about third-party antennas, as long as the third-party antenna lines up with one of these. In other words, if, you know, because these are the antennas that we took to the FCC and certified for compliance, right? So if a third-party company makes a 13 dBi antenna, that's great. If they make a 14 dBi, we didn't submit that for qualification, right? And you know, and it's possible that, you know, we can, through the DART connector, have a 20 dBi antenna and dart it up so that the AP, you know, turns everything down like it does for 13 down to the 20 or whatever. But that's more futuristic. That's more, you know, what we're going to do in software later. You know, when you make a piece of hardware, and I've said this a lot of times, it's like making cupcakes. You pull it out of the oven. If the center of that cupcake's gooey, you can't go back and recook it, okay? So the hardware is able to do many, many things. And you'll hear things like, you know, RF fingerprinting and all of these other, you know, we tout things that are hardware capable. And then time tells whether we put the energy in the software to do it, right? So right now, this product supports these antennas. Any third-party antenna that's of like design and gain may be used, and it's really simple to look at the chart and see. If somebody decides to make something at a much higher gain, we probably have to submit it for qualification or work with them in a third-party lab to do it. But that's the antennas. And then I got one last slide, and that's just in theory kind of stuff. It's kind of a goofy slide here, but what I wanted to say was, if you can split that connector and go off into two different directions with two different antennas, if you can, don't put them so that they aim into each other. Don't put them too close together. You get RF isolation a lot of different ways. You get RF isolation by getting distance away from each other. You get it by height separation. If I have two omni antennas, remember an omni antenna, looks like this, radiates in a 360-degree pattern. It doesn't end fire, right? It doesn't send the signal out the top of it. It goes around. So if I put an antenna here and then I go up 5, 8, 10 feet on the tower, put the second one up, they're not going to shoot down at each other. I'm going to get better isolation using height separation than I do side by side, because side by side, they're both going into each other, right? So when you do this, you get isolation by turning transmit power down. And that's what we do with the internal units. When you look at an internal AP and all the antennas are inside, we create a micro and a macro cell, because the micro, I got to turn the power way down to get my isolation, So, you don't want to do a dumb mistake by doing an install and pointing the antennas too close to each other or pointing them into each other. Keep in mind, the farther away frequency-wise the antennas are, better isolation. The lower the transmit power on one of them, better the isolation. Polarity, if something is vertically polarized, which is normal, maybe on an outdoor link, I go to horizontal polarity. Maybe I've got a vertical polarity doing clients in the near field and a horizontal backhaul link or something, so polarity can help you. Height separation, physical separation, things like that. There's no one way to do it. You kind of have to test it and see what works. And in the picture over to the right, they took, this is like a 3800. They basically took a patch antenna to shoot up the escalator. So at Cisco Live, if you had your phone, you got connectivity riding the escalator, but the other 5 gig radio and 2.4 pointing at the registration desk, and so I've got two completely different cells running in that environment. Or I might take a product, you'd mentioned about different gains and things. I might take an antenna that's supposed to be this way to go out really, really far, and I might put it on a tripod, put it this way, so it shoots right in the ground. What I'm doing is I'm forcing myself to have a much smaller cell, and I might litter more of those out there. So you can play with external antennas. External antennas are a huge deal in my opinion, because if you're an RF expert or somebody with the knowledge of doing it, you can do so much when you can control that antenna. It's kind of like, it's like an audio buff, right? The speakers and, that are this big aren't as good as the when you can focus and do things, right? So I kind of think of it like the difference between the speaker and your phone and having a big horn out on the stadium or fairgrounds, shooting out.